doing odd, even functions. There's another option that's neither, but mainly it's odd or even is what we're looking for. This is 2.2.1 part 2. So this is going to be the last lesson this week that we'll have to cover with all the stuff going on this week. Okay. So when we're looking at odd or even functions, one key point is we're looking at symmetry. We've already talked about that, so you're pretty clear on kind of what symmetry is, looking at symmetry. Other key points to really consider and follow up with is this has nothing to do with the exponent. So just because x squared is an even number for the exponent, that doesn't mean it's an even function. This has nothing to do with the exponents. They play a role in the experiment we're going to do. We're going to do an experiment on each of these functions, and from there figure out if it's odd, even, or neither. But it has nothing to do with the exponents where we can just look right off the bat, oh, it's the exponent's even, so it must be even. That has nothing to do with it. Okay. Mainly about symmetry. We're looking, you want to think of this as an experiment where we plug in negative x for x. We're going to do that experiment, and then we're going to compare to the original function, which will give us our three options. This comparing to the original function is going to be pretty simple, and that'll tell us if it's odd, even, or neither. Okay. These are types of functions. When I said it was about symmetry, odd, so you might want to write this, and from there we'll be able to figure out if we're really going to be dealing with this. Odd has symmetry about the origin. So this is symmetric around the origin. So this is symmetric about the origin. So a function that looks similar to this, or that works, would be something like this. You see? It's almost like a parabola twisted. It's a third power. So looking at this, we know that this function, if it looks like this, would be odd because it's symmetric around the origin. If you were to spin it, think of a propeller, it would look the same if you spin it 180 degrees. It would always look the same because it's symmetric around the middle point. Now, what do all of our, in this unit, what do all of our functions create? What kind of shape are we dealing with? Parabolas, right? Is there any way for a parabola to be symmetric around the origin? Could you move that anywhere where it'll be the same if you were to flip it? It would look exactly the same. Where could you do it? Where could you do that? Yeah?
If the vertex is the origin.
Let's see what happens. So that's the one that I thought of as well when I was thinking about this question. So let's see what happens if we have, if our c value is 0. So our y-intercept is 0 if it's like so. So in this case, can I spin it around the origin where it's going to look exactly the same? Is there anywhere that I can make that happen? You can imagine this is like a propeller. If I were to spin this one whole or half a turn, 180 degrees, we would end up with the same shape. We'd end up with the same graph. But there's really no way that I could spin this unless I do a whole 360 degrees where it'll look the same. Because this actually doesn't have symmetry around the origin. This has symmetry about the y-axis. Symmetry around the y-axis is what even functions end up showing. So let's go and put that on even functions. So here is an even function. It's symmetric around about the y-axis. Symmetric. Y-axis. Okay, so actually we're going to stick with this one example up here. Now, since we are not going to be dealing with functions of this power, we're not going to have these until the next unit, I'm going to be very straightforward and say odd doesn't happen in unit 2. So not in unit 2. We want to learn what it is right now. We're going to look at it. But as far as what you'll see in classwork and homework, this option just isn't going to happen. So I want you to know, if you're looking for it to happen, it just isn't going to happen with the equations we're dealing with right now. So this is going to be for later, but we'll still kind of look at this and work this out. So remember our experiment. You want to think of this as an experiment, right? So step 1 is to do the experiment. Step 2 is going to be to compare. Step 3 is going to be to identify which one of those we end up with. So let's bring it all together. And actually, I'm going to do the even one first because I want you to get used to that. The odd number has some factoring that I'm glad we get another moment. We'll do that in the next unit. But let's look at even to start out with. Okay. What is the experiment? The experiment is we plug in negative x for x. So watch what I do here. I'm going to go negative x for x. Does everybody see what I just did? Instead of x, I'm going to plug in negative x. Here we just have to simplify. We don't have to solve anything. We don't even have to graph. Today's lesson in classwork homework doesn't have any graphing. It has you going and just looking if it's odd, even, or neither. So it's going to be a key step we have to figure out. So let's work this out. If you're not sure where to start, you're going to expand everything. Negative x to the second power is negative x times negative x. So here we have a negative times a negative. That gives us, thank you, a positive times another negative gives us a negative. So 3, and there's x times x, so that's x squared plus 4. Everybody okay with that, how I got down to that? Okay. How's that water? Okay, we did step 1. We did the experiment. Step 2 is compare. So I'm going to take this, and I'm going to compare it to that. It's the same. So when we're comparing, basically, you're looking at the original. You're looking at the original equation and comparing to what we got after our experiment. Because they're the same, I know that this is an even function because I end up, when I plug in negative x, it looks exactly like the original equation. So we're going to say, oh, it's the same. So it must be even. What? All right. So the answer is even. I'd want to see this as your answer. You're either going to say if it's odd, even, or neither. And I need to see this work. So this is the work I need to see. Because I want to see you plug it in. These get tricky when you get more terms to plug in and do in your head. So just show that work, kind of like prove that you know how to do it. All right, so what are we doing? We're doing an experiment where we plug in negative x for x. Then we compare to the original equation. We're going to have 3 options for how those 2 equations relate, the original and the experiment. And that's how we're choosing odd, even, or neither. Okay, pretty straightforward. How are we feeling? Thumbs up, sideways down. Thumbs up, sideways down. Okay, thumbs up, sideways down. Okay, let's do neither. We'll have another option to look at, another example, and we'll go from there. The situation with neither, when we go to compare it at the end, when we plug in negative x, we do not get, it's not equal to the original or to the negative version of the original. So when we get our f of negative x, it doesn't look like my requirement for odd. It doesn't look for my requirement for even. That's why it's neither. Okay, does that make sense? It's not fitting in any of those categories. So I'm going to do my experiment. Here's my experiment. F of negative x is equal to 2 times negative x squared minus negative x plus 4. The reason why I want you to use parentheses and really use parentheses here is that the negatives are going to get confused. It's going to be a lot to juggle in your head if you have a bunch of negatives and positives combining. All I did was my experiment. This was step 1. You still have to simplify it before we can compare it. So let's go ahead and expand, simplify everything we need right here. So 2, negative x, negative x. I'm going to make that positive. I just combined this middle term here, negative times negative x. I just made it positive x. There's no need to rewrite that. We can do that the first step. But these two right here, what's a negative times a negative? Positive. I have 2, and x times x is x squared plus x plus 4. All right, now I have my f of negative x all worked out. So what I do is, next step is going to be to compare. We're going to compare the original and look at our new experiment version. Are they exactly the same? No. We'll learn that the odd, which we don't have to touch in this unit, it potentially could be odd, and there's a way we could try to factor it to see if it's odd, but it actually is neither because this is my sample problem. But at this point, because we know we are not dealing with odd in this unit, because they're just quadratics at this point, then we're going to look and just see, does it match? Is it the same? No, it's not. So my step 3 would be to identify this is neither. Neither. So my work that I want seen is this. I want to see that work. And I want to see your answer, the neither. You don't have to graph for this stuff. You don't have to graph. All we're doing is doing the experiment. We're plugging in that negative x for x, simplifying and comparing it. Okay. Hopefully we're getting a couple more thumbs up. We'll see after this one. I'm going to do the odd one right here. I'm going to do the odd one, but remember this isn't in this unit, but I want it in the notes anyway so that you know what we're doing. Okay. My experiment is plugging in negative x Good. All right. Everybody see what I did? This might be hard to recognize right off the bat, so I'm going to expand it. All right, just combine the negative 4 and the negative x to get positive 4x. Now I have this first term expanded, now I can deal with it. Negative times a negative. Positive times a negative? Negative. Good. So we end up with negative 2x to the third plus 4x. This is actually an honors type step, this next one. Okay, so all the honors folks, that's you. Let's look at this expression here. Can we factor out a negative from both these terms? And if so, what would we get? So what I'm saying is, can we factor out a negative from the expression, and what would I end up with? I take a negative out of both of those terms. Don't say it out yet. Think about it for a sec. Okay, good. 13 minutes. All right. Some people catching on? You can do that? Okay. If you can't, watch this. Maybe you'll get a step up. If I factor out a negative from the first term, negative 2x to the third, I end up with 2x to the third. I just pulled the negative out of that. Now the thing is, when we have a term that's positive and we want to take the negative out of it, you kind of have to think in both directions. So I'm factoring out a negative, but then after I get that, let's double check ourselves and distribute it back in and see if we get what we started with. So you can always go both ways in algebra to find if you're doing it right, you substitute it in, correct? So instead, this is going to be negative 4x. The reason I know that is, if I distribute the negative here, I get negative 2x to the third. If I distribute the negative here, negative times negative, gives a positive 4x. So now let's look at, we've done step 1, the experiment. Now we're looking at step 2, which is to compare these two. Right? Let's compare these two. What do they look like? They're not the same. What's different? Isaac.
They're negative versions of each other. They're opposite.
Right? So this is the right expression here. That's the right expression. This part, it's the same as up here, but the negative's out front. So now the reason why this would be odd is because when we plug in a negative x, we end up with negative of the entire function. You see, we plugged in the negative x here, worked it down, we ended up with the negative of the original function. Here's the original, no negative up front, nothing. Okay. File that away. This is what we'll deal with in the next unit. This is how we do the odd. But mainly today, and for this unit, we're going to have even or neither options using this experiment method. All right, thumbs up if it's feeling good. Thumbs up, you can do the classwork. Okay, great. Thumbs sideways, you'll need help with the classwork. All right, good. Good job. All right. Let's see. Oh, I guess I should say you should subscribe. You should subscribe.